Today is day 14 of Unit 4. We started today with a warm-up, so pause the video, try the warm-up, and then play to check your answers. So the first one, I need to first get that set equal to 0 because I can see it's cubic and I know that I'm going to factor that to solve it, but I can't factor till it's set equal to 0. So I have 2x cubed plus x squared. I'm subtracting 72x and I'm subtracting 36, and when I do that it equals 0. So I'm going to group those two and those two. So GCF x squared, I'm left with 2x plus 1. I copy the 2x plus 1. I realize that I have a negative 36 when I factor out the 2x plus 1, and that equals 0. So GCF between these two terms is 2x plus 1, and I'm left with x squared minus 36, and that equals 0. I can see that x squared minus 36 factors, and it's set equal to 0. So 2x plus 1 set equal to 0, and x plus 6 and minus 6 set equal to 0 gives me plus or minus 6. So 2x equals negative 1, so x equals negative 1/2. So we have three solutions, negative 1/2, positive 6, and negative 6. Number 2, finding the vertex. So you have two options with that. You can either think about the fact that this is 2x plus 1 and another 2x plus 1. So I can pull out a 2 from each of those. And when I do that, I have 2 times the quantity x plus 1/2. So I have 2 2's, so I have 2 times 2, which is 4, and I have x plus 1/2, the quantity squared. So that's one way to do it. Now it's in vertex form, and I can see that the vertex is negative 1/2, 0. The other way involves first multiplying out the binomial, so squaring 2x plus 1. So when I square 2x plus 1 correctly, I get 4x squared plus 4x plus 1, and that equals y. Now I need to get that from standard form into vertex form so I can complete the square. Factoring out the 4, I'm left with x squared plus x. The 1 stays out. I take half of 1, which is 1/2, and square it, which is 1/4. That completes the square. 1/4 times 4 is 1 that I randomly added. So I'm going to subtract the 1 that I randomly added. So I have a 4 out front. I have x plus 1/2, the quantity squared, and 1 minus 1 is 0. So again, I have the same vertex form that I had here using the other approach, which means the vertex is negative 1/2, 0. Okay, so either technique is fine to get you the vertex. Okay, so today we worked on application problems, and we're going to work on these not only today but the next couple of days in preparation for the end of the unit and your test coming up later this week and individual tests next week. So as we go through these examples, these application problems, just make sure you're really following along, taking good notes. Because application problems tend to be the hardest part of the unit. It's hard for students to apply what they've learned in the unit. So do your best, try and follow along, ask questions if you have any. So the first question is on page 28, so you'll have to find that in your packet. It's number 1. So I'll read the problem here. It says a spaceship is approaching a star and is caught up in its gravitational pull. When the ship's engines are fired, the ship will slow down, momentarily stop, and then hopefully pick up speed, move away from the star, and not be pulled in by the gravitational field. The engines were engaged when the ship was 750,000 miles away from the star. After 1 minute, the ship was 635,000 miles away from the star. After 2 minutes, the ship was 530,000 miles away from the star. So it says, list the 3 points from the information in the paragraph. Okay, well, before we can list points, we better determine what our x and y are. Let's define our variables. So reading that, we know we have time and we have distance, and we need to figure out which depends on which. So if you think about that, time is independent, which means that x, because x is the independent, is going to be time. And in the problem, it mentions that they're in minutes. okay? Which means the distance depends on the time, so that's y. And the distance is in 1,000 miles, thousands of miles. Okay? So it says we want the distance to reach a minimum and then increase again over time. So it's going to come down, it's going to be decreasing, reach a minimum, and then increase again over time. Well, what I just drew from the information we were given is a parabola. So a parabola best models this. So we're going to figure out what the coordinate points are here. And then once we figure out the coordinate points, we're going to come up with the equation for this parabola. So back to the paragraph I read a moment ago, if x is time and y is distance, then our first coordinate point would be 0, 750. And then 1, 635, and 2, 530. So if I substitute those 3 coordinate points into my equation, now I have to figure out which one. We don't know the vertex. So we don't know, we can't use vertex form, we'll use standard form. Remember, we did this earlier in the unit. So I'm just substituting in x and y into that equation to create 3 different equations. So substituting in 750 for y, a times 0 squared plus b times 0 plus c. Let me simplify that. I'm getting 0a plus 0b plus 1c. My second equation, 635 is equal to a times 1 squared plus b times 1 plus c. 635 is equal to 1a plus 1b plus 1c. And the last equation, 530, is equal to a times 2 squared plus b times 2 plus c. So 530 is equal to 4a plus 2b plus 1c. So those are my 3 equations. So 3 equations, 3 variables. We have a system of equations. We know how to solve that. We're going to use matrices. So we're going to use the coefficients 0, 0, 1, 1, 1, 1, and 4, 2, 1. The variables a, b, and c, and that equals the constants, so 750, 635, and 530. And we know how to solve that. We know this is a, this is x, equals, this is b. So we know that we're going to multiply both sides of the equation by a inverse, which gives me I times x, and I times x is x. So x is a inverse times b. That's what you're going to figure out. So you're going to enter matrix A in your calculator, matrix B in your calculator, and then have the calculator figure out a inverse times b. And when you do that, you'll get matrix X. So take a moment, try that. So once you've done that, you should get 5, negative 120, and positive 750. So remember, I'm substituting into y equals ax squared plus bx plus c. I'm substituting in for a, b, and c. So 5 goes in for a, so 5x squared. Minus 120 goes in for b, so x, and then plus c, which is 750. That is my equation, which is part A. Okay, so all this was part A. Now we're ready to move on to part B. So the question says, if the ship comes within 50,000 miles of the star, the shields will fail and the ship will burn up. So just reading that question, at the beginning of that question again, if the ship comes within 50,000 miles of the star, think to yourself, looking at the variables that we defined, when they say comes within 50,000 miles of the star, are they giving us the x or are they giving us the y? Well, they're saying 50,000 miles. So that means they're giving us the y. So if you take time to think about that, it actually helps you know what to do. So it tells me that I'm supposed to be putting 50 in for y. Okay, now think about that. First of all, we know that we were given in that statement. We were given the y value because y is the distance. But think about why I wrote 50 in for y instead of 50,000, because y was defined as the distance in thousands of miles. Okay, so I want to put 50 in, not 50,000. So now I have a quadratic equation which is set equal to 50. I need to solve that. All of the techniques that we know for solving involve the quadratic equation being set equal to 0. So the first thing I'm going to do is subtract 50 from each side, giving me 0 equals 5x squared minus 120x plus 700. Now that is actually factorable, so I'm going to factor it, but remember, if it didn't factor, our other options would be completing the square quadratic formula. Square roots, unfortunately, would be out because it has an x, but we could use any of those techniques. This one I'm going to factor because it does factor. First of all, it has a GCF. And second of all, the trinomial factors into two binomials should be x minus 10 and minus 14. So that gives me two solutions, 10 and 14. Now, we have to answer the question, though, which says, if it comes within 50,000 miles of the star, the shields will fail and the ship will burn up. Use your equation to determine whether the spaceship has failed to escape the gravity of the star. So the minute we were able to solve this and we got real number solutions rather than imaginary or complex, we know that the ship will come within 50,000, because when we put 50 in for y, we did get real number x values. So because we got real number x values, then we would say, yes, the ship will burn up. The ship will burn. Okay, and now we have to say when. Well, we have two answers here. So think about it. Back to our little sketch. We had this parabola, right? So it's saying that at 10 for x, the y was 50. And it's saying then again at 14 for x, the y is 50. Okay, so really all that that's saying is here, at this point here, the ship, after 10 minutes, because 10 is x, and x is minutes. After 10 minutes, the ship is within 50,000 miles of the star. So we know that anytime it's within 50,000 miles of the star, it burns up. So right here, the ship's burning up, which technically, in terms of the problem, means it's done. It's the ship's burned up and it can't go any further. In terms of the parabola that models this scenario, there would actually be a second answer. If the ship did continue on, it would go down until it reached the minimum, and then it would go back up. And then once again, after 14 minutes, it would be within 50,000 miles of the star once again. We realize, though, that if at 10 minutes the ship burns up, the ship is no longer there to burn up again after 14 minutes. But the ship will definitely burn up. At 10 minutes, after 10 minutes, it will be within 50,000 miles of the star, therefore it'll burn up. So the ship will burn up after 10 minutes. Okay? Now, realize, had we solved this equation and we got complex or imaginary numbers here for x, then we would be saying that the ship did not burn up, because then it did not come close enough. It didn't come within 50,000 miles of the star. But because we got real numbers, that means that at that real number, at 10 minutes, the ship is within 50,000 miles, which means it burns up. Okay, so that's the answer to part B. Now, we're going to take a look at number 2 on the next page. So this problem is about a jackrabbit jumping over a 3-foot-high fence. In order to just clear the fence, the rabbit must start its jump at a point 4 feet from the fence. Okay, so I'm reading all this information, but it sounds to me like I need to visualize this. I need a picture. So I'm going to start with the ground, and I'm going to draw the fence. And it says this jackrabbit is jumping and just clearing the fence. So notice I'm making it go just over the fence. Now, the fence is 3 feet high. And it says the jackrabbit starts its jump, which is starting it right there, 4 feet away from the fence. Well, the fence is here. So if we know what we know about parabolas is that they're symmetrical. So if it's 4 from here to where it starts its jump, then we know it has to also be 4 on the other side. So we know that. So now we have our picture. Now, the next thing you'll do is you'll figure out if you were going to put these on a graph, a coordinate plane, where would you want to put the origin? Now, there's a couple places you could draw the origin. You could draw the origin here, or here, or here, or here. It doesn't really matter where you choose to put the origin. You'll just figure out the other coordinate points based on that. So I think when I asked in class, most students wanted to put the origin here. So we're going to label that 0, 0. Again, you could put it elsewhere on the picture though. So if that is 0, 0, then the origin's not part of the parabola. So the part that is part of the parabola would be this point right here, and that point there. All three of those are on the parabola. So I'm going to figure out their coordinates. If this is 0, 0, and this is 3 feet tall, the fence, that means this coordinate point, which is the vertex, is 0, 3. Similarly, if this is 0, 0, and this is 4 feet over, then that means that this is at 4, 0. And if this is 4 feet in the negative direction, then this is negative 4, 0. Okay, so now we have 3 coordinate points that are all on a parabola, which means if we wanted to, we could do the problem like we did the last one, using standard form and matrices. But we also, because we know this time that one of the 3 coordinate points is the vertex, we also could use vertex form. And since we did the other problem the other way, let's use vertex form for this one. So I'm going to substitute the vertex in for h and for k. And then I'm going to pick either positive 4, 0 or negative 4, 0. It doesn't matter. Now I can't use 0, 0 because it's not on the parabola. And I can't use the vertex because I've already substituted that in for h and for k. But I can use either of these 2 points that are also on the parabola. So I'm going to use 4, 0. And I'm going to solve for a. And again, we did this earlier in the unit, so it's just a review. 4 minus 0 is 4, squared is 16. So I have 16a plus 3. I'm solving for a, so subtracting 3, I get 16a, and then a is equal to negative 3/16. So my equation is y equals negative 3/16 times x minus 0, the quantity squared, plus 3. And that's my equation. Okay, now realize that equation is in vertex form, which is fine. It didn't specify. But had I used this technique, then my equation would be in standard form. Either's fine for this problem. Now, we were not, in this problem number 2, we were not asked any follow-up questions, but you certainly may be asked follow-up questions. So we probably should take a moment and define our variables. Okay, so let's let x be, now let's think about this. X would be the distance, the horizontal distance away from the vertex. Horizontal distance from the vertex, which is the fence. Okay, and the y we know is the height of the jump. And of course, both of these are in feet. Okay, so I could very easily ask you a question like, how far away was the jackrabbit from the fence when it, or in order to jump 30 feet high, or something like that. So then what you would do is substitute 30 in for y, because 30 is the height, and then you would solve for x. Okay, or I could ask you something similar to that. I could say, how high would the jackrabbit jump if it was starting its jump at 2 feet away from the fence, or something like that. In which case you would put 2 in for x and solve for y to figure out the height of the jump. Okay, in this particular problem, again, that was all we were asked, just to write the equation, but it's important that you understand how to apply that equation as well. And that was it for examples for today. Tonight you're going to work on finishing up page 29 and then also all of page 30. And when you're doing those, make sure you draw a picture, make sure you label the important points on the picture, and then decide, is this a candidate for vertex form? If you know the vertex, then yes. Or standard form, if you have 3 points on a parabola but you don't know the vertex, then you would use standard form. So coming up this week on Thursday, you'll have a team test, and next week, remember, Monday and Tuesday, you'll have an individual test.